Okay, pre-calculus. We're on Unit 5, Day 1. We are going to quickly go over this concept first. If you take the square root of 9, you know that is just 3. But, however, if you have a function, you take the square root of x squared, you end up getting the absolute value of x. This ends up being a plus or minus 3. It's because this implies that we have a restricted domain, as well as the inverse functions that we did in our previous chapter. This implies we have a restricted domain, and we did a lot of talking about that, where if you're trying to find the inverse sign of, I don't know, real quickly, for example, if you're trying to find the inverse sign of like 1/2, for example, y is positive first quadrant and second quadrant. However, when we restrict the domain, we know that there's only one solution. So now today we're going to be solving trig equations where we are not we don't have a restricted domain. So let's go ahead and solve these equations just like we would a regular equation. So square root of 3 minus square root of 3, we get 2 sine of x equals negative root 3. Wow, that's messy. Divide both sides by 2, we get the sine of x equals negative root 3 over 2. Well, where is the sine of x equal to negative root 3 over 2? We've got it in two places here. That's where we have the tall angles and it's negative. Okay, boom, boom. Well, that's also pretty messy, but that's 4 pi over 3 and 5 pi over 3. So x equals 4 pi, 4 pi over 3 plus, if I go around again, I'm going to have another coterminal angle at the same exact place. And I can go around an infinite number of times. So it's plus 2 pi k. I also have another solution at x equals 5 pi over 3 plus, I can go around 2 pi however many times I want. So 2 pi k. And there are your solutions. All right, let's go to the next equation. So we've got, when you subtract 5 and divide by 5, we get the tangent of theta equals negative 1. Well, where does the tangent of theta, where does it equal negative 1? We've got that in quadrant 2, and we've got it in quadrant 4, right? At 3 pi over 4 and 7 pi over 4. However, if I write this as theta equals 3 pi over 4 plus pi times k, I'm going to include, if I add pi to 3 pi over 4, I'm going to get 7 pi over 4, which is the other solution. So I don't need to write the other solution. I can just write that one solution. Take a look at the U-try. If you want to try that ahead of time before you look at the answer, go ahead and do that. That's a really, really good idea, especially because we're not getting as much practice this year. So solving quadratic types. So sometimes you'll get an equation that's quadratic, and you've learned different ways to solve quadratic equations. The first way is by factoring. So if you were to look at this equation from Algebra 2, and those cosine squared thetas were x's, okay, that's a 2x squared plus x minus 1. How would you factor it? Just like I have right below it, okay? Except for instead of x, there's a cosine. But that's all I did. I used that same factoring skill. Now, I use the zero product property. I set each of those factors equal to 0. And just go ahead and solve them separately. Okay, and I get the cosine of theta equals 1/2. Where does that happen? At pi over 3 and 5 pi over 3. So I have two solutions. Whoops. Two solutions right here. Seriously? There we go. Two solutions right here. Okay, now we also over here have the cosine of theta could also equal negative 1. Where does that happen? Only in one location. So we also have a third solution right here. Let's go to B. So let's go ahead and solve this. If I add 2 and then divide by 4, I get sine squared of x equals, that's 1/2, right? So if I take the square root of both sides, I'm going to end up with plus minus, right? So I'm going to get sine of x equals plus or minus. This is the square root of 1/2. Now I'm going to have to simplify that. Maybe I should do that on a different slide. Okay, plus or minus square root of 1/2. So that's equal to square root of 1 over the square root of 2. So that's equal to 1 over root 2. Rationalize. I'm getting root 2 over 2, plus or minus. So go back to that slide. Oh, shoot, where was I at? Here. Okay. So sine of x equals plus or minus root 2 over 2. Well, where does that happen? Well, it's plus or minus. So it happens at all those middle angles. We don't have to write all those solutions out, because if I halfway around the circle here, okay, and this is 0 and this is pi, halfway is these, and these are middle angles. They're all the same distance apart. This is pi, they have a difference of pi over 2. So I could just pick one and write x equals pi over 4 plus pi over 2k. Then I don't have to write every single one out, because if I take pi over 4 and add pi over 2, I get 3 pi over 4. If I add another pi over 2, and keep going to all the solutions. Okay, so try the U-try. Press pause. And here are your solutions. Press pause again if you need it. We're moving on to example 3. All right, so these are just another way to factor, still factoring, but these are where I think it gets kind of fun. So if I got the sine of x, it's like the sine of x over 1 plus, this is this tangent, we know is equal to the sine of x over the cosine of x. All right, so I rewrote the whole equation. All I did was rewrite tangent as sine over cosine. Now, those are two fractions where I can undistribute or factor out or GCF out a sine of x. So if I factor out the sine of x, what I'll have left is 1 plus 1 over the cosine of x. You might have to look at that a little bit to understand what I did there, but it's just factoring and unfactoring. Or another way you can think about it is if you want to re-multiply this out, okay, and distribute the sine of x to 1 and sine of x to 1 over cosine of x, you'll see that those are the answers. All right, now I have two different factors here, right? I've got a sine of x and I've got a 1 plus 1 over cosine of x. Now I can set those separately, each equal to 0, using the zero product property, and I will get, oops, I didn't set this one equal to 0. All right, so where is the sine of x equal to 0? Two places, so that's just x equals, I'm going to write that as pi times k, because 0 plus another pi, plus another pi, and so on. All right, now this one ends up being 1 over the cosine of x equals -1. That is secant. Secant of x equals -1. Where is that? That's at, boom, right there. Okay, so, and you can always, I would probably start here and look at this one and say, all right, what does cosine of x have to equal in order to make this a true statement? Clearly it's going to be -1. So where does the cosine equal to -1? So at pi, so that's just x equals pi plus, now to get to that, again, you have to go all the way around the unit circle, 2 pi. So that's plus 2 pi k. So we've got, really, I mean, this is kind of repetitive. I would probably circle both of them. All right, try the U-try if you need more practice, which I think you do. And press pause and take a look at it. And now we are moving on to example 4. And this is where things start to get a little tricky and also kind of fun. All right, so sometimes we're going to have to find solutions of weird angles that are not on the unit circle, okay, like 3 theta. All right, so we're just going to change that. We're going to do the whole problem like that was just another variable, and usually I like to use a u. In some of the solutions below, I've used an x, and it gets confusing because if you use x, you might forget to resubstitute the 3 theta back in at the end. So we're going to do this whole problem with u, and then we're going to resubstitute the 3 theta back in at the end. All right. So if I say let u equal 3 theta, then I rewrite the problem, and instead of writing 3 theta, I just write u. Well, now we just have the problems that are just like the ones we just did. Well, where does that happen? That happens at the middle angles. Whoops. Okay, so we've got that at positive, right? So that's going to be at pi over 4. All right, so let me write that. Ooh, maybe a different color and not as thick. Okay, so x, or no, not x, u. U equals pi over 4 plus 2 pi k, and u equals 7 pi over 4 plus 2 pi k, right? Now those are the solutions if that was u. However, that u is actually a 3 theta. So we're going to resubstitute our 3 theta back in there and just rewrite the whole equation. Instead of u, put 3 theta. I can barely read this. Sorry, guys. All right, now if I just divide through the whole thing by 3 to isolate that theta, remember everything has to be divided by 3, and we never divide fractions by 3, we always multiply by the reciprocals. So that ends up being theta equals, this is going to be pi over 12 because you're multiplying by 1/3 plus, what is that, 2/3 pi k? And this is theta equals, now that's going to be 7 pi over 12, and I had to make sure that didn't simplify, and it doesn't. 2/3 pi. I'm just writing as 2/3 pi k, but you can leave it like that if you'd like. All right, so those are my two solutions there. All right, so B. So this one's a little bit funkier, but we're still going to let u equal theta minus pi. So when we do this, a lot of people at this point start dividing both sides by cosine, okay? If these cosines and sines were x's, you wouldn't divide both sides by x's. If like this was like 2x squared equals x or something like that, you wouldn't just divide both sides by x. But you would, because that x could be, that x could be 0. So you would subtract the x from both sides, right? And that's what we need to do here as well. Otherwise, it's not quite accurate. It might look accurate, but it's not quite accurate. You're going to lose out on one solution. Okay, so I am going to move the cosine over. So 2 sine squared u cosine u minus cosine u equals 0. Okay, so now, oh shoot, I'm running out of time. All right, I think I can do it. Okay, I'm going to factor out a cosine. So cosine of u in parentheses 2 sine squared of u minus 1. All I did was factor out a cosine, and now I'm going to set each of these factors equal to 0. 2 sine squared u minus 1 equals 0. So I'm getting the cosine equals 0. Where is that? That's at u equals pi over 2 plus pi k, right? I'm thinking. Yes. Okay, now this one is the sine of u. Shoot. Sine of u equals plus or minus root 2 over 2, if you solve that. And then we substitute back in our theta minus pi, and we add pi. Now, when you add something to both sides of an equation, whether it be a number or anything, okay, this is a number, all we're going to do, you're just adding it once. So what's going to happen? It's just going to add another pi. So that's going to stay the same because we're already adding pi how many ever times we want to add it. How many ever times we want to add it. All right. So theta is pi over 2 plus, it doesn't affect our pi k. The other side, we've got, I think we've already done this one. U equals pi over 4 plus pi over 2k, right? Yeah, we have. And in that, from there, we substitute our, theta minus pi back in for our u. And when hold on just a second. When I add my pi, I think I made a mistake. So when I add my pi, I should be adding it to this pi over 4. So this is theta. Yeah, I totally did. That ends up, we need to add this pi to the pi over 4. Shoot. Now I'm confusing you. So this is 5 pi over 4 plus pi over 2k, which means in a different color that I made an error over here. And I have to add a 3 because when I add pi, we have to add it to the pi over 2, which makes that 3 pi over 2. Sorry about that, guys. Somebody would have caught that if we were in class. And I have the U-tries here you could take a look at, and all these solutions are on my webpage as well, and my Google Drive. All right, peace out.